Hello and welcome everyone. Let's see one more example on the construction of DFA type 6. Construct a DFA that accepts set of all strings that starts with substring w1 and ends with another substring w2. For example, w1 equals to a and w2 equals to a. This means that we have to design a DFA that accepts set of all strings that starts and ends with a symbol A. Now to design a DFA for this language, we have to first find the basic string that belongs to this language. Here, A is the basic string for this language. Since this A starts and ends with A. Now we have to represent this basic string by using a state diagram. So let's start with the starting state Q0. Reading the A symbol from Q0 leads to the state Q1. Since this A belongs to this language, so we have to accept this A. Therefore, we make this state, that is Q1, accepting state. Now, any number of A's comes after this A should be accepted. That's why we make this transition on A. Now, what if the machine reads a symbol B after these A, that is from the state Q1? In that case, we switches to another state Q2 on the transition B. Since this string does not belongs to this language, so we do not double circle this state. Any number of B comes after this string, we just revolve in Q2 states on encountering the symbol B. And there is a possibility of occurrence of A after these B. So if A occur after this B, that means if A occurs in Q2 state, then we have to accept that string. So we switch to the state Q1 on encountering the symbol A from Q2. Similarly, what if the machine reads the symbol B in Q0 state, which indicates that the string starts with the symbol B. So whatever comes after this B cannot be accepted since it is already started with symbol B. That's why we make a dead state Q3 and switches to that dead state Q3 on encountering the symbol B from Q0. Now, whatever comes after this B should not be accepted. That's why we just revolve in this Q3 state on encountering the symbol A or either B. This is our required DFA. Let's see one more example of this type where W1 equals to A and W2 equals to B. This means that we have to design a DFA that accepts the set of all string that starts with A and ends with B. So let's find the basic string that belongs to this language. The basic string that belongs to this language is AB. Now we have to represent this basic string by using a state diagram. So let's start with the starting state Q0. Reading the first A from Q0 state leads to the new state Q1, and then reading the B symbol from Q1 state leads to the state Q2. Since this string belongs to this language, so we have to accept this string. Therefore, we double circle this Q2 state. Now, any number of B's comes after this string should be accepted as this string already starts with A and ends with B. That's why we make this transition. Now, what if the machine reads a symbol A in Q2 state? That means reading A after these B's. In that case, we have to just check whether the symbol B presents in the last position of this string or not. This checking of B in the last position is performed by this transition. So we make this transition on encountering the symbol A on state Q2. Now, what if the machine read the symbol A in Q1 state? That means it already reads a symbol A to reach in Q1 state, and what if the machine reads another A in Q1 state? In that case, we have to only check whether B comes after this A or not. So this checking of B is performed by this transition. So we make this transition on input A. Similarly, what if the machine reads a symbol B in Q0 state? That means the string starts with the symbol B. In that case, whatever the symbol comes after this B can't be accepted. That's why we make a dead state Q3 and switches to the state Q3 on encountering the symbol B in the state Q0. Now, whatever comes after this B can be accepted. Therefore, we just revolve in Q3 state on encountering the symbol A or B. This is our required DFA. Let's see one more example of type 6 where W1 equals to AB and W2 equals to BA. That means we have to construct a DFA that accepts the set of all strings that starts with AB and ends with BA. For this, first we have to find the basic string that belongs to this language. The basic string that belongs to this language is of length 4, since this 2 and this 2, that is A, B, B, A. Now we represent this basic string by using the state diagram. Let's start with starting state Q0. Reading the first A leads towards the state Q1. Then reading the B symbol leads to the state Q2, and reading the next symbol B leads to the state Q3. Then reading the next A symbol leads to the state Q4. Since this string belongs to this language, so we have to accept this string. That's why we make this Q4 state as a accepting state. Now, what if the machine reads a symbol B in Q4 state? That means B after this string. In that case, we have to only check for a symbol A whether it is present after this B or not. This checking of A after B is performed by this transition. That's why we move to the state Q3 after reading a symbol B in Q4 state. Similarly, what if the machine reads a symbol A in Q4 state? That is A after this string. In that case, we have to further look for the string BA is present or not after this A. This checking of BA is performed by this whole transition. Therefore, we move to the state Q2 and reading a symbol A in Q4. Similarly, what if the machine reads a symbol B in Q3 state? In that case, the machine already reads the symbol A, B, B to reach to the state Q3 from Q0, and reading one more B in Q3 state, that is B after this string. In that case, B is already present as a last symbol, so we have to only check for whether A is present or not after this B. This checking of A is performed by this transition. Therefore, reading B in Q3 state, we just revolve around Q3 state. Similarly, what if the machine reads the symbol A in Q2 state? That means A after AB, since this symbol is already read by the machine to reach in the state Q2. In that case, we have to only check whether BA is present after this A or not. So this checking of BA is performed by this whole transition. That's why we just revolve in Q2 state after reading a symbol A in Q2 state. Similarly, what if the machine reads the symbol A in Q1 state? That is A after this A, since this A is already read by the machine to reach Q1 state. This indicates that the string starts with AA, therefore does not belongs to this language, and whatever the symbol comes after this AA can't be accepted, since it already starts with AA. That's why we make a new dead state Q5 and moves to that state after reading a symbol A in Q1 state. And whatever the symbol read in this Q5 can be accepted. That's why we make this transition. Similarly, what if the machine reads the symbol B in Q0 states? That means the first symbol read by the machine is B. Here in this case, the string starts with B and hence cannot be accepted, and whatever the symbols come after this B can be accepted. So here we moves to the dead state Q5 on reading the symbol B in Q0 states, and whatever the symbol comes after this B can't be accepted. That's why we just revolve around Q5 on reading AB after this B. So this is our required DFA. Similarly, you can try to construct other DFA that is based on this type 6. If you have any difficulty, then please leave the comment. For more and more updates, please like, share and subscribe this channel, and thank you for watching this video.